students, welcome to Sunil's tutorial. I'm Sunil Mirwani and today we'll be doing this chapter called as Nature of Chemical Bonds. Now, what do we understand by a chemical bond? What do we understand by a chemical bond? Atoms or ions combine together to form various molecules. The force of attraction that keeps atoms or ions together in a molecule is called as a chemical bond. The force of attraction which keeps atoms or ions together in a molecule is known as chemical bond. Next, now let's see what does the electronic theory state. Electronic theory states that electronic theory of valency was propounded in 1616 by a scientist called as W. Cosell. Now he says that only the outer shell valency, only the electrons in the valency shell take part in bond formation. We've already learned this in school also. The valency electronic configuration of inert gases is stable. Right? All known elements try to make their valency similar to those of inert gases. Fine. So in this, they either give or share electrons, and that leads to the formation of bond. Fine. Do we get this thing clear? So let's try to see the electronic theory of valency. The electronic theory of valency was put forward in 1916 by the scientist W. Cosell and G.N. Lewis. These were the two scientists that put forward the valency theory. Now, what is the electronic theory of valency? W. Cosell, K-O-S-S-E-L. Right? Now, what does the theory state? The theory states that only the electrons in the valency shell, take part. Only electrons of valency shell take part in bond formation. Right? It also says that the valency electronic configuration of inert gases is very stable. The valency electronic configuration of inert gases is very stable. Fine. The elements having electronic configuration other than inert gases have a tendency to acquire inert gas configuration either to complete duplet. Duplet means 2 electrons in the outermost shell, or octet. Octet means 8 electrons in the outermost shell, either by give, take or share of electrons. Elements having electronic configuration other than inert gases have tendency to acquire have tendency to acquire inert gas configuration. Have tendency to acquire inert gas configuration by gain, transfer or sharing of electrons. By gain, transfer or sharing of electrons. Right? Now,
So what exactly is gas configuration? Inert gas configuration?
Inert gas configuration, inert gases except helium, all of them have 8 electrons in their outermost orbit. So most of the elements want to have 8 electrons in their outermost orbit except helium. Helium has 2 electrons in its outermost orbit. The property of having 2 electrons in its outermost orbit is called as duplet state. The property of having 8 electrons in the outermost orbit is called as octet state. So all elements want to achieve octet state except hydrogen, which has to attain duplet state to make its outermost orbit stable, because we are saying that electronic configuration of inert gases is the most stable electronic configuration. All elements have a tendency to become stable, for which they need to acquire electronic configuration which is similar to inert gas configuration. Right, do we get this thing here? Okay. Now, let's see, this was, what are the different types of bonds? There are 2 different types of bonds that are formed when you have atoms combining. One is called as the ionic bond. Right? Ionic bond is also called as electrovalent bond. So ionic bond or electrovalent bond. Now what is this bond? This bond is formed when there is a transfer of electron. When there is a transfer of electron from metallic to non-metallic atom, there is going to be an electrostatic force of attraction that is going to be there is going to be an electrostatic force of attraction, and the bond that will be formed due to this electrostatic force of attraction will be called as ionic bond. Questions. So why will there be a force of attraction? Because if the metallic atom gives an electron, it will get converted into a positively charged ion. The non-metallic atom will accept an electron and will get converted into a negatively charged ion. We know that opposite charges attract each other, and that's the reason why there is going to be that force of attraction between them. So what is ionic bond? The bond is formed by transfer of electrons. Bond is formed by transfer of electrons from metallic to non-metallic atom. Right? Now, there is an electrostatic force of attraction between the oppositely charged ions, and this electrostatic force of attraction is called as ionic bond. So I can say the inter-ionic electrostatic force of attraction between oppositely charged ions is called ionic bond. Let me explain this to you with an example. Let us consider sodium. Sodium has electronic configuration 281. Let us consider chlorine. Chlorine has electronic configuration 287. Sodium has 1 electron in its outermost orbit. Fluorine has 7 electrons in its outermost orbit. Sodium, if it loses that 1 electron, then the second electron will become the outermost orbit, and the outermost orbit would then have 8 electrons, which would be a stable electronic configuration. Chlorine, if it accepts one electron, it will have 8 electrons in its outermost orbit and it will have stable configuration. Thus, when sodium combines with chlorine, sodium gives one electron to chlorine, chlorine accepts that electron. Since sodium gives the electron, sodium gets converted into a positively charged ion. Chlorine, since it is accepting the electron, gets converted into a negatively charged ion. Since the ions are oppositely charged, there will be a force of attraction, and this force of attraction gives rise to a bond, which is your ionic bond or electrostatic bond. Fine, do we get this thing here? Next. So that was ionic bond. The other bond that is formed is called as covalent bond. Right? What is covalent bond? Covalent bond is formed by mutual sharing of electrons in the participating atoms. Okay? So when a bond is formed by sharing of electrons, then that is called as covalent bond. Bond formed by sharing of electrons of participating atoms is called covalent bond. Right? So a bond which is formed by sharing of electrons is called as covalent bond. Fine, do we get this in here? Now, let's explain this to you with the help of an example. Let's consider chlorine as electronic configuration 287. So one chlorine atom has 7 electrons in its outermost orbit, combines with another chlorine atom which again has, we'll show this with the help of dots, has 7 electrons in its outermost orbit. When the two chlorine atoms combine, they will share a pair of electrons. They will share a pair of electrons. So you will have chlorine 1, 2, 3, 4, 5, 6, 7 will share with one more chlorine 1, 2, 3, 4, 5, 6, 7. So this electron pair is going to be shared by both the chlorine atoms, and the bond that would be formed here would be called as covalent bond. So covalent bond is formed by sharing of electrons, right? Now, thus what we understand from this discussion is that every atom wants to have its electronic configuration similar to the inert gas element electronic configuration. That means every atom wants to have 8 electrons in its outermost orbit or valency orbit, and this rule is called as the octet rule. So what does the octet rule state? The octet rule states that every in the formation of chemical bonds, atoms lose, gain or share electrons, so that the outermost orbit of the atom should have 8 electrons in it, which is similar to the inert gas configuration. So what is octet rule? Octet rule says that in formation of chemical bond, atoms lose, gain or share electrons, so that the outermost shell outermost shell of an atom contains contains 8 electrons, right? So this is how a chemical bond is formed using the octet rule. Fine, do we get this thing clear? Now, what are the drawbacks of octet rule? Why is this rule not used? The first drawback for octet rule is that octet rule does not explain to us the interacting forces in a covalent bond. A bond is formed, that means there should be some forces. There should be a positive and a negative ion. When a covalent bond is formed, there is no ion. So where is the force of attraction between them? The rule fails to explain the interacting forces in a covalent bond. Right? The theory only explains to us that how a bond is formed. It does not tell us the geometry of the bond. It does not tell us the geometry of the compound. The rule fails to give us the geometry of the compound form. Now the rule says that every atom wants to make 5 electrons in its outermost orbit, 8 electrons in its outermost orbit. Let's see the formation of phosphorus. Phosphorus has 5 electrons in its outermost orbit. It combines with 5 chlorine atoms to form a compound phosphorus pentachloride. This is PCl5. We know that we have a compound called as phosphorus pentachloride. What is unique about this is, look at the outermost orbit of phosphorus. By sharing of electrons, if I consider the sharing of electrons, there are 10 electrons in the outermost orbit. But the rule says that there should be only 8 electrons, only then a compound is formed. Here I have an atom, I have a compound which has 10 electrons in the outermost orbit and yet a compound is formed. The theory fails to explain this. Similarly, I could also give you another compound, say boron trifluoride. Boron has 3 electrons in its outermost orbit. It combines with 3 fluorines to form the compound boron trifluoride, BF3. We know that such a compound exists, right? Now if you look at the outermost orbit of boron, there are only 6 electrons in the outermost orbit of boron and yet a compound is formed. What does the theory say? It says that, the octet theory says that till the time we do not have 8 electrons in the outermost orbit, a compound cannot be formed. Here I have a compound formed with 10 electrons, here I have a compound formed with 6 electrons. The theory fails to explain to me why. Right? So the theory, it fails to explain the phenomena of expanded octet where you have 10 electrons and incomplete octet. Right? So the theory is not able to explain to us why there are certain compounds that are formed with 10 electrons in the outermost orbit and why there are certain compounds which are formed with only 6 electrons in the outermost orbit, where the theory clearly states that till the time you do not have 8 electrons in the outermost orbit, a compound would not be formed. Fine, do we get this thing here? So do we understand the drawbacks of the octet theory? Since there were drawbacks in the octet theory, a new theory was proposed. The next theory to be proposed is called as the valency bond theory. Right? Everyone's understood the octet theory. Octet theory states that there should be 8 electrons in the outermost orbit for a bond to be formed. And we just saw that there are drawbacks in this theory. Since the theory fails to explain these points, therefore a new theory was propounded, and the name of the new theory is valency bond theory. Now this theory was propounded in 1927 by Hilter and London, and later by Pauling and Slater in 1931, explain the geometry and the shape. So there are 4 scientists who can take credit for this theory. The theory was initially proposed by Hilter and London in 1927, and the theory was then further modified by the scientists Pauling and Slater. In 1931, explained the geometry and shape of different molecules. Explained geometry and shape of different molecules. Right? So now that we know when was it proposed and by whom was it proposed, let us try to see what are the main postulates or what are the main points of this theory. The main postulates of valency bond theory is that valency bond theory says that only when overlapping of atomic orbitals takes place, the spins of electrons are mutually neutralized and electrons get paired. Valency bond theory takes place that a bond is formed by overlapping of orbitals. How is a bond formed? A bond is formed by overlapping of orbitals. Right? It does not use Rutherford's atomic theory, but it uses Bohr's atomic theory. Bohr's atomic theory stated that an atom is made up of orbitals. So he said that the valency bond theory says that bond is formed by overlapping of orbitals. The strength of the bond depends upon the extent of overlapping. Right? Only those orbitals which have same energy levels would overlap. During overlapping, only those orbitals which have electrons with opposite spins would overlap. Complete overlapping of 2 orbitals is not possible, because then the 2 nuclei would come close to each other and would exert a force of repulsion. The geometry and the shape of the compound form would depend upon the orbitals taking part in overlapping. That is my valency bond theory. Fine, do we get this thing clear? Let's write this down. A bond is formed by overlapping of orbitals. Only orbitals having similar energy level take part. Only orbitals of the outermost shell having similar energy levels. Wait, I'll just reframe this. Only orbitals of outermost shell take part in overlapping. Right? The strength of the bond depends upon the extent of overlapping. Depends upon extent of overlapping. Complete overlapping is not possible. Not possible due to the repulsion from the nuclei. Right? Only orbitals having electron with opposite spins overlap. Orbitals with electrons having opposite spins overlap. Fine. The shape and the geometry of the molecule depends on the orbitals that overlap. Right? What are the interacting forces? The interacting forces is the nucleus of one atom attracts the electrons of the other atom and vice versa. Right? The interacting forces the nuclei of one atom exerts a force of attraction on electron of other atom and vice versa. Also, the two nuclei exert force of repulsion on each other. So thus here you can see that most of your drawbacks of octet theory are removed. I know the geometry, I know my interacting forces, and let's see what are the different types of bonds that can be formed. So this is my valency bond theory, right? So the geometry and depends upon shape and geometry depends upon the orbitals that overlap, right? Interacting forces I've told you. Okay. Now, here one more thing that you have to know is that the number of covalent bonds that will be formed is equal to the number of unpaired electrons present in an atom. Number of covalent bonds that would be formed depends upon the number of unpaired electrons present in the atom. Fine. Strength of overlapping I've explained to you, and our complete overlapping is not possible. Now let's see what would be the shape and geometry that would come out from a valency bond theory. Let's see the different types of overlapping. The different types of overlappings that you have is one is S orbital overlapping. Right? S orbital overlapping. Right? Or let me explain this to you with the help of the formation of hydrogen molecule. Right? Now, hydrogen molecule has only one electron. The electronic configuration of hydrogen is 1s1. It has one orbit, it has s orbital, and the s orbital has only one electron. Now we know that s orbital is circular in shape. This is your x-axis, y-axis, and z-axis. Right? Let's assume that this is the spin here. The spin of this is this way. This will overlap with another hydrogen atom which will have an opposite spin. X, Y and Z will overlap with another hydrogen atom having an opposite spin to form S overlapping. X-axis, Y-axis, Z-axis, and your electron density increases in the area of overlap. So there you have the electron density increasing. This kind of bond is called as S overlapping, right? And from the orbitals we now also know the geometry and the shape of the bond hydrogen molecule that will be formed.
So what is the difference between this H atom and that H atom?
These are two different hydrogen atoms combined to form one hydrogen molecule. The difference between them is they have electrons with opposite spins. In one of them the electron is spinning clockwise, in the other one that is here and here. Right? They have electrons with opposite spins. Fine, do we get this thing clear? Okay. Next kind of overlapping. So this is your S overlapping, where you have one S orbital overlaps another orbital, and the overlapping takes place along the axis. Fine, do we get this thing clear? The next kind of overlapping that you have is PP overlapping. Let me explain this to you with the help of formation of chlorine atom. Right? Now, electronic configuration of, instead of chlorine, let's take fluorine. Right? Now, let's see this electronic configuration of fluorine. Is 1s2, 2s2, 2p6, now 2p5, so 2px2, 2py2 and 2pz1. That's my electronic configuration. Let's see how does this look like.
So why do we write that X, Y and Z down?
Because the p orbital has three orientation along x, y and z axis. Right? Along along each axis you can have two electrons. So along x axis and y axis it is filled. It's only along z axis that it is not filled. Right? Now let's show you how this looks like. Right? This is how the p orbital would look like along the three axes. you would have three lobes on the three axes, right? This is along x, y and z axis, right? Let's assume that here you have an incomplete orbital, right? A half-filled orbital with just one electron with one spin. This will combine with another chlorine atom. This is one chlorine atom. This will combine with another chlorine atom. X, Y and Z, where you will have an opposite spin. Right? This is going to combine with another chlorine atom. Right? So you have two chlorine atoms having half-filled orbitals, right, with opposite spins. When they overlap, so it's fluorine, fluorine, sorry, you're taking fluorine, right? So in that case, here you would have an overlap that would be formed this way. Right? The electron density will increase in the area of the overlap. The two lobes will become unequal. The size of the lobe in the direction of overlapping will become higher, will become bigger. This is x-axis, this is z-axis, this is y-axis, right? This is going to be y-axis and this is going to be z-axis. So this is going to be a PP bond or a PP overlapping, right? You have a proper bond that is formed due to the actual overlapping that takes place. Fine, do we get this thing here? So this is how you would have a PP overlapping, and this will also give rise to a peculiar geometry for the chlorine molecule. Next, let us see the next type of overlapping. The next type of overlapping you have is sp orbital overlapping. Right? sp orbital overlapping, where you have an s orbital. Let's explain this to you with the formation of hydrogen fluoride. Let's see the formation of hydrogen fluoride molecule. Hydrogen atom. It has only s orbit. It has only s orbital and it has a half-filled electron in the s orbital. This is hydrogen atom. This will combine with fluorine x, y and z axis, where you have an electron with opposite spin. Right? They will overlap each other to form a bond like this. This is fluorine atom.
So in the hydrogen atom, that also is XYZ, right?
Yeah.
Narrow.
YZ.
X, Z and Y.
So then,
This is X, Y, Z. I've already written in fluorine.
XZ.
XZY, no?
X, Z, Y. Fluorine. X, Z, Y. Right? Now let's see this. You have hydrogen combining with this. The lobes will become unequal. Electron density increases in the area. This is going to be X, Y and Z. This is Y and Z. So this will be the geometry that will be formed. This is called as an sp orbital overlapping. You have an s orbital overlapping with a p orbital that gives rise to sp orbital, which gives rise to a peculiar shape, geometry, and we also know the interacting forces, right? So do we understand the valency bond theory? Right? Okay, we'll stop this here for the day. Thank you very much.